Hello, this is our project, C Sharp Programming Language by Miranda Nichols.
And Carson Stell.
The goal of this project was to learn about C Sharp and how it works, and to better understand programming languages as a whole. C Sharp stood out to us because it has a wide range of uses with similarities to C and C++, and it is rapidly growing in popularity.
So the medium program that we wanted to implement for this from the beginning was actually a calculator with an interactive UI. This application lets you can enter in the numbers with your keyboard, but you can also click on the numbers on the screen. We'll delve deeper into that during the medium program implementation section further on. Now, the sections of the report, as you can see down there, are the introduction to C Sharp, which we're on right now. We've got history, followed by basic features, the tutorial, the medium program implementation. We're going to evaluate all of the features in C Sharp as well, see how they compare to other languages, and then of course we're going to reflect over the entire project. Up in the top left corner of the screen, you can see a progress bar with the 1 on it. That signifies that we're in section 1, so whatever the lowermost number showing on that is shows you which section that we're currently on.
So now we're on history. C Sharp was originally created because Microsoft was jealous of the release of Java by Sun Microsoft Systems. So they hired a Danish software engineer called Anders Heilsberg with the goal of taking back the competition from Java.
And at first they were going to call the language cool, standing for C-like object-oriented language, but they later changed it to C Sharp because C++ was already object-oriented at the time. C Sharp is actually just based off of C++ with another C++, as you can see in the diagram below. Pretty cool. And C Sharp and Java, they at first did resemble each other in a lot of ways, but over time they have grown more unique as they both developed. C Sharp was initially released with the .NET framework, and that's when that was released, and we'll go more in depth about that later, but that plays a big role in applications developed today. Just going through a few of the updates here. In Update 2.0, generics, partial types, nullable value types, and iterators were introduced. In version 5.0, and the never-seen-before asynchronous programming's async and await model were introduced. In Update 7.0, out variables, pattern matching, local functions, discards, and throw exceptions were introducced. In Section 8, or in Section Update 8.0 was the first ever update to release and focus on the .NET Core, which allowed developers to create apps and services that were finally not only restricted to the Windows operating system. Macs and Linux and Chrome could all use those as well. And the rest, not from 9.0 to 12.0 updates, introduced things like static anonymous functions, extended property patterns, and more. C Sharp's current status in the industry is very popular. Companies that actually were developed using C Sharp were Microsoft, they made it. Stack Overflow was not only made using C Sharp, but uses C Sharp in their front end as well. It was developed C Sharp by C Sharp in the front end and back end. And City National Bank. Major projects that were built with C Sharp include Unity and Godot. Pretty much anything that uses game development. Xamarin as well makes apps and games for phones. Microsoft Office. As we said before with Microsoft. Jobs that might require you to know some C Sharp is, of course, game developers, .NET developers. .NET's also Microsoft and hence C Sharp. And full stack developers because C Sharp handles the front end and the UI. C Sharp's, as you can see in the TOB Programming Community Index, it is still on the rise and it's actually about to surpass Java. And is one of the best investments that programmers of today can make is to learn C Sharp. I mean, it's only going to become more popular. It's going to overtake Java soon, and many jobs are going to start looking for people who know C Sharp. So let's get on it. Here's section 3. We're going to go over basic features, and we all know that basic features of any programming language is what makes that programming language stand out among the crowd in terms of how it handles those features. Python is known for its readability, C++ for its high adaptability, and Java for its robustness, while C Sharp is often referenced as being the best language for creating great UIs, and it's revered for its easiness to learn, as well as its robustness as well, just like Java. As for paradigms, yes, C Sharp does support paradigms, including object-oriented programming, which uses a bottom-up approach, procedural programming, which is very similar, uses a top-down approach, and dynamic and functional programming. All of these basically allow you to either reference other objects in the program or create sub-programs to break down and tackle problems in an easier way. As for data types, C Sharp actually includes two types of data types. We've got value types and reference types. Value types are the more standard types. We've got 15 of those. Most of them, most being 10, are actually integer types. It takes up most of the space. There's a lot of flexibility you can use there. And then three of them are some form of double types, and then the other two are just bool and character. Now, reference types are used to reference objects or other classes. That comes in handy when you're doing more complex programs.
C sharp has order of execution of program, which is determined by control flow. Usually, code is ran from first line to last line, unless something interrupts the flow of the code. Normal flow, which is sequential flow. Then there is selection statements, if, else, jump statements, which is break, continue, return, go to, loops, switch statements, expectation handling. And then now we have examples of every single statement, switch statements. We've already learned in C++, most of these we learned in C++, is a menu. Selection statements are if, else if. And then now we have loops. For a for loop, it executes a block of code a specific number of times. A while loop executes a block of code as long as the condition is true. A do while loop is similar to a while loop, and it executes the block code at least once before checking the condition. Then we have jump statements, which is break, continue, return, which is used to exit a loop or switch statement. Continues, skips to the current iteration of a loop and moves to the next iteration. Exit, which exits a function and potentially returns a value, and then go to, which goes to a part of the code. And then next we have expectation handling, which is try, catch, finally. It can try, catch, finally is used to handle unexpected or expectational situations that may occur during program execution. A catch contains the code that might throw expectation. A try contains the code that might throw expectation. Catches the handles specific types of expectation, and then finally, it contains a code that is always executed regardless of whether expectation is thrown or not. And then expressions. Expressions are a combination of operators and operands, which defines the expression, stanza, and order operators. C# is always evaluated left to right. This is an example, A equals B plus C divided by D, where C# first does 10, which does C divided by D, and then it will do the plus statement, which is 2. And it uses order of precedence. And then these are some symbols that C# uses, and however it goes from left to right or right to left. And then subprograms are a block of code that performs specific tasks, and these subprograms can be called from anywhere in the program. This helps organize code, improve readability, and promote reusability. And then this also helps lessen amount of memory and reduces time it takes to execute a code, because you can jump to a subprogram if you want to. And then object orientation. C# is object-oriented, which means that this language is able to work with classes and objects. The four main principles of object-oriented is abstraction, polymorphism, encapsulation, inheritance, which basically means that abstraction hides unnecessary details, focusing on what an object does rather than how it works. Encapsulation binds functions and data into classes, allowing for abstraction through public methods and properties. Polymorphism enables objects to perform in various ways, including dynamic polymorphism via function overriding and static polymorphism through method and operating overloading. Inheritance allows classes to inherit characteristics from other classes. And then expectation handling, which is what we already went over. It execute errors are errors that occur when application is executed. We do this by the try, catch, finally, and then throw. These are some examples of C# code. We already went over it, so.
All right, so section 4 is our tutorial, and as you can see to the right, the objective of this tutorial is to write a hello world program. Line 1 starts with us defining the class hello, and within that, everything within it is defined by the opening closing curly braces on lines 2 and 8. Everything inside of that defines hello. Inside of that, we get our static void main, which is the main driver of the entire program. Everything inside that is what we're going to be running. In line 5, we can see a comment signified by the 2 slashes. The compiler ignores that line, and right under that is the thing that makes the program do its job in the first place, which is the right line, hello world.
C# has many major features that make this program different from others. Some of these features are the use of .NET, which utilizes features like language interoperability to work seamlessly with other .NET languages. It simplifies programming with automatic garbage collection, eliminating memory management tasks and potential errors. C# lacks pointers, priorities type, safety, and simplicity. Boolean values are strictly true or false for accuracy. It's a modern language supporting web services and is type safe, preventing data loss and ensuring secured type conversions. These are some of our resources that will help beginners and even advanced people learn more about C#. We have a tour of C#, which is a Microsoft website, which is really good at understanding C# and building more comfortability with the language. And then you have a tutorial of C#, which you can put in code and it will tell you if your code is true or false. And then this book that we also looked at, which we like, which is Pro C# 10 with Net 6, and it will help anyone with C# learning.
So here's our medium program implementation. As we saw before, it's a calculator application with clickable buttons as the user interface. And it does a great job of showing how UI is handled in C# and why C# is so special with that. Here's a little preview of what the user interface looks like on the app. That was the main idea of why we chose this program, to show off how C# handles that in and of itself. And we'll see more of that in the demo. But here's a little preview of what that's going to look like. As for namespaces and classes, basically namespaces and classes are essential and you have to include them in every program in C#. In this one, it didn't come in a lot of use, but in other ones, you'll see it used a lot more. Private methods were used almost exclusively in this program, basically to connect each button with the actual number in the program itself. And for the variables that we used 4, num1, num2, option, and result, all having to do with the expressions entered into the calculator. Now, the number buttons and negative buttons work in a pretty straightforward way. Whatever button you press for any of those, that number is just inputted onto the calculator screen. For the operator buttons, on the other hand, whenever you press that button, the option variable is set to that operator, and then num1 is set to the current value on the screen. The screen is then cleared. Sets you up for num2. Then you can enter num2 with those buttons, just like you did for num1. You press the equal button, and that evaluates the equation and gives you a result, and that also sets the result variable. And the delete and reset buttons work also in a pretty straightforward way. The delete button, once you press that, just takes the last character of the string off of the screen, and the reset button clears the screen and resets num1, num2, option, and result back to their initialized values. Without doing that, it's very essential you do that. Without resetting those, you are not resetting the calculator. You're just clearing the screen. In conclusion, design of the UI was easy, and us already knowing C++ helped a lot with design, with understanding and analyzing the code. And the preview of what the app looks like in Visual Studio helped a lot with developing it. However, the class and namespace being required, even though we didn't need it, was a little bit weird and a bit of a hassle. The redundancy didn't let us, redundancy within the code didn't let us preview a lot of the features as C# as we thought we would get to see. All right, so here is the program for the medium program implementation for the calculator. Now, in Visual Studio, there's 3 tabs that you need when you're developing a UI-based app. There's this one that has all the logic for the actual calculator itself. This one just goes over it shows you what the design is going to look like. Very helpful. This one is generated by Visual Studio. After you make this design, it just puts all of this code in here that links this with the calculator itself. All right, so let's go ahead and just run it and see what happens.
So when you run it, you click on these little buttons. So you can click on 7, and then if you want to plus 7 by something, you hit plus, and then you click another number. I'm going to click 6, and then click equals, and then it'll equal 13. And it also works for times situations. So 16 times 3 equals 48.
So any basic arithmetic operation works on this. Uh, let's go over real quick each of the code snippets for when we're pressing the button. So when I said redundant earlier, this is what I meant. That basically just goes over each of the button presses between the numbers 0 through 9 and the minus button or the negative button. So let's do -5 plus 3. Basically those numbers being entered with hitting it with the buttons is what makes it show on the screen. That's what this code does. And that also allows, let's see, down here when we've got multiply, divide, plus, and minus, those operators actually set the option to whatever the operator was, and then it also sets num1 to whatever button was on the screen. So 6 plus 3, hitting plus sets num1 to 6, and when we hit 3, that's now on the screen. When we hit the equals, we got that. Whenever we hit equals, it's going to set num2 to 3. And right after it does that, num2 equals whatever was on the screen. We're going to parse that out, and then depending on whatever the operator was, we're going to have different expressions that compare num1 and num2. And we're going to display that result back on the screen. And then here's how the delete and the clear functions work as well. Delete just removes the last bit of text from the screen, and then the clear button clears the screen as well as setting all of these back to their initialized values.
For evaluation, we evaluated criteria that determine the readability and writability and reliability of C Sharp and how it handles these characteristics and how it performs relative to other language in regards to each of these criterias. This is a picture from the book of each of the characteristics and how they do with writability, readability, and reliability. Control structures are similar to control flow, but these are the structures that make control flow work. Some of these, like I stated before, are if-else statements, for, while, and do-while loops, break, continue, return, go to, and switch statements. A control structure that is unique to C# is the for each loop. There's also conditional statements that control structures use. There is a sequence structure, which is a type of structure that is built into C#. And although there is no lack of flexibility when using control structures, because there's so many options, it can be overwhelming at times.
So as for the simplicity and orthogonality of C#, C# is a relatively simple language compared to C++, not as much compared to Python, so shouldn't be too hard to pick it up, especially if you already know C++. C# is not very orthogonal. Things can become a bit confusing when you're looking at operator overloading, reflection versus static typing, and the async and await operators versus synchronous code. But as long as you're not opposed to a challenge, these lacks in orthogonality will not bite you. As for data types, as we went over before, the variety of data types can give the programmer lots of flexibility. There are a lot more value types than there are reference types within C#, and again, that's because of the intense and large number of int data types. 10 of them are integer types, and 3 of them are double types. Most of them are numbers. All the types can seem intimidating at first, but once you understand how to use them and in what cases to use them, they become a lot easier to understand and handle. As for the syntax design in C#, it's very similar to C and C++, and of course Java. Things like the using keyword, ignoring white space, the curly brackets and semicolons are all carried over. However, to write in C#, you're going to use the method writeLine to write to the console, which is different. This versus static, they are used in C++, but a lot more commonly in C#. Namespaces are also used in different ways than in C++. Some things that are still necessary is that are in every program, you're required to use namespaces, which is a little bit infuriating at times. The syntax design is harder to understand and adapt to than in languages like Python, but if you're already familiar with C++ or Java, picking up the details is not a hard thing to do. So does C# have support for abstraction? Well, of course, the answer is yes. It's based off on C++, and it's done through generics, inheritance, and polymorphism through object-oriented programming. If you know how it works in C++, it works the same way in C#. Now, as for expressivity in C Sharp, if a language is expressive, then it's easy to write code for that language. That's what expressivity means. We had to do a bit of research beforehand on that. C Sharp is about in the midfield when it comes to expressivity. You can tell what the code says for the most part. However, it's a lot easier to understand if you already know C++. Here you can see an example of expressive code right here. It reads kind of like English. It's easy to understand. And then here is less expressive code. Accomplishes the same task, just a lot faster, but it's harder to read. Sometimes you have to sacrifice that. And the reason I say it is pretty expressive still is here's an example of a language called BF. It's an abbreviation. It's not expressive at all.
Type checking, which tests code for type errors in a program by either the compiler or during the program execution. Some of these ways are type of, as is. These are some codes that C# uses. Type of is an operator that uses to find and return the type of built-in types a C# program has. The as operator explicitly converts the result of an expression to a given reference or null value type. And is operator calls runtime type identification, and it is used to check if an object can cast to a specific type at runtime. If true, it returns a Boolean value. Expectation handling is a mechanism that separates code and then detects, handles expectation circumstances from the rest of a code or program. It allows for the ability for the program to intercept runtime errors and take corrective measures and then continue aid to the program readability. C# has extensive capabilities for expectation handling, and some of these are try catch, try finally, try catch finally code, which we've had already gone over before in this slideshow. Restricted aliency is two or more distinct names in a programming language that can access the same memory cell. And there's an example of this using console equals system.console. It helps writability because if you were to change a public name to a code, you do not need to go through a massive search and replace the whole code, and instead use an alias to change the name of a code.
Finally, we've got section 7, or reflection. So, Miranda, how was the experience of studying a new language to you?
It was very interesting. I learned a lot more about C#, and it was kind of difficult at times because there's a lot more that goes into programming language than I thought, but in the end, it made me a better programmer, and I learned a lot more. Okay, Carson, what advice would you give someone who is starting to learn C#?
Well, there are a lot of free tutorials online. There's actually one on YouTube that's posted by Microsoft, and the link to it is right there. And just a little piece of advice. If you are even slightly interested in learning C#, please do it. It is the fastest growing language currently, and it's about to surpass Java, as we said earlier. And because you already know C++, if you're watching this video, you know C++. Learning it is gonna be very fast. It's actually a lot easier to handle than C++ itself. There's gonna be a lot of companies wanting people to know it moving forward. So, yeah, you should learn it. All right, Miranda, what advice would you give to someone who is starting to work on this project?
Don't slack off. There is deadlines, and these deadlines can come up fast, so just make sure you do your work on time, and then you'll be good to go. So, Carson, if you had to do another medium program implementation, what would you do differently?
Well, we'd probably pick a program that has a bit more features in C# shown off. You know, at first we picked that calculator program, which was great. And I think it shows off C# UI abilities very well. But, you know, it wasn't as complex as we were hoping it would be. And we'd probably just pick something that did show off a bit more of C# and how it is unique. Here are our references, and thank you for watching.
Thank you.